Hello, 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 everybody, and welcome. Happy Monday. It's good to see you all. Let's get into it. It's review day today. We're reviewing two-digit by two-digit multiplication. It's something we covered extensively in fourth grade and at the beginning of the year this year just as a review, but I thought it would be appropriate and really helpful to take a day and just reintroduce ourselves to this idea of two-digit by two-digit multiplication, and essentially taking a multiplication expression where you're breaking both factors into two different parts to find four different partial products. This is going to be really helpful tomorrow when we start to tackle what happens when you multiply one mixed number by another mixed number. Think about the composition of a mixed number, and I bet you can already start to think about how we're going to tackle mixed number multiplication if we're thinking about two-digit by two-digit multiplication. Over there, that's what you're going to need. Your something to write on, something to write with. Please be writing while you do this. It's helpful. And then down here, thereabouts, there they are. There's our I cans. I can use an area model to visualize and solve two-digit by two-digit multiplication expressions. And I can define partial product. Let's jump right into it because it's something we've done before. So when we're thinking about an area model, we're thinking about whatever the length of this is times whatever the width of this is going to give us our area in the middle, and we're multiplying length times width when we do it. So using the area of a rectangle is a really effective model for helping to visualize multiplication. Now, if we have a two-digit by two-digit multiplication expression, let's have 15 times 16, let's say, just for a little variety, okay? What we're imagining is that we have a rectangle that is 15 units in one direction and 16 units in the other. Maybe it's a 15-inch by 16-inch piece of construction paper. Maybe it's a 15-foot by 16-foot room. Maybe it's a 15-mile by 16-mile national park, right? In any case, by multiplying our length times our width, we're going to know the area in the middle. So we can safely say this is 15 by 16. And remember, what's going to help us is to break our length and our width up into smaller, more manageable chunks by using our place value, being able to say our 16 is going to be equal to 10 plus 6. And we can actually divide that into two line segments, one that's 10 long, one that's 6 long. Same thing here. Divide this into 10 plus 5. One that's 10 long plus 5 long. Then what you are left with is 1, 2, 3, 4 partial products. And when I say partial product, I mean smaller multiplication equations that when you add them up, create one larger equation or one larger answer. So if you were to find the area of these four rectangles, one that's 10 by 10, one that is 6 by 10, one that is 5 by 10, and then one that is 6 by 5, and you added up all the areas of these four partial products, you would get the area of the whole thing. So let's do that. Some of you already did it in the chat because you are very familiar or you've been practicing on your own, which that's some extra work there. 10 times 10 is 100. 6 tens is 60. 5 tens is 50. 6 times 5 is 30. And then we'll add them up. We can use this side over here that's got some space. Wherever there's space, you can add them up. 100, 60, 50, and 30. So we've got all zeros and the ones. Let's add up our tens. 3 plus 5 is 8. 8 plus 6 is 14 tens. So we're going to regroup our 10 tens and keep the 4 extras here. And then 100 plus 100 is 200 for a total of 240. Okay? In standard algorithm, let's take a look at this in standard algorithm because there are the same parts here. We're actually going to zoom in over here. Actually, I'm going to stand on this side and put this over here because I want this empty space right here. If we were to take this and put it in standard algorithm where we're stacking the two on top of each other, okay, you'll be able to see here that we are actually doing the same process. 6 times 5 is 30. And I actually really like to do standard algorithm this way, and putting all of our partial products below rather than carrying it up to the top. It's a little clearer to see. 6 times 5 is 30, and then 5 times 10, because this is 110, 5 times 10 is 50. Okay, then moving to our other digit down here. 10 times 6 is 60. And 10 times 10 is 100. And as you can see there, those are the same 4 partial products as we have here. 30 and 30, 50 and 50, 60 and 60, 100 and 100. Okay, so 2 strategies, exact same thing. Okay, those of you that do the shorthand version of standard algorithm, it might look a little bit different. Where you're kind of doing our adding and multiplying at the same time. So 6 times 5 is 30, and you're going to put the 3 up here and add it. 5 times 10 is 50, plus 3 is 80. Essentially what you've done is you put these 2 in the bottom row together. 50 plus 30 is 80. Then you do the tens. 10 times 6 is 60. I'm going to carry my 6 up. 1 times 1 is 1, plus 6. Anybody? Sorry, 6 goes there. No, it doesn't. See, this is how far I've gone back, is I don't even remember how to do the standard algorithm correctly anymore. 1 times 6 is 6. There we go. 1 times 1 is 1. That's what I did wrong. See how long it's been? I legitimately don't use the shortcut anymore because I practiced area model so much. I don't use it anymore, so I'm out of practice. But essentially, 100 plus 60 is 160. So all the shortcut does is it puts the bottom row together and the top row together. Still, the same partial products. All right? So we're going to go to our digital whiteboard and we're going to try a couple. Okay? Start with the area model. It's a little clearer to see, and we've practiced it a little bit more. Well, at least I have. I haven't practiced the shortcut in a bit. So 26 times 14. So we're going to set up our rectangle here. $20 plus 6. 10 plus 4. Okay, so we have 26 on one side, 14 on the other. Then find your partial products. 10 times 20, or 1 times 2 with our 2 shortcut zeros. 10 times 6, 20 times 4, and then 4 times 6. And then add them up at the end. A couple of you will stop there, but you don't know your total product until you add up your partial products. 200 plus 60 plus 80 plus 24. Okay, I did that one for you. This next one, you're going to do on your own. Starting with setting up our area model, finding the 4 partial products you need, and then adding up your partial products. Let's try, I'll switch it to yellow just for a little variety. Let's go with 23 times 41. Go ahead and try that one on your own. Okay, and if standard algorithm works faster for you, okay, start with standard algorithm, but then do area model anyway. Okay, try it both ways, just to give yourself a little bit more of a stretch with your mathematical thinking. Okay, whichever one you do most comfortably, do that first. Then try some other ones and confirm what you got as your answer for the second one. Okay, I see an "oh, I get it now" in the chat, which is the best possible response. I love the "oh, I get it nows." You always had it. You just needed to like hear it in a different way or think about it enough times. All right, you always had it. So I get lucky. I get luckier and luckier every year because just smart mathematicians just keep showing up in my class every single year. It's amazing. Like you'd think one year I'd get, no, it's almost like everybody's good at math. You just got to put the work in and do a little bit of practice and struggle through it. Get some help, ask some questions, and then you'll get there. So let's try this. I'm going to do my comfortable method first, and then I'm going to do my uncomfortable method of the standard algorithm. So here's my rectangle. Oh, thank you. Divide it up. 20 plus 3, 40 plus 1. So we have 20 times 40, or 2 times 4, with our 2 shortcut zeros. 40 times 3, or 4 times 3, with 1 shortcut 0. 20 times 1, well, that's just 20. And then 1 times 3, that's just 3. And now we can add them up. 800, 120, 20, and 3. 2 plus 2 is 4. 8 plus 1 is 9, for a total of 943. And I'm seeing I got the same answer as people in the chat. Yes. That leads me to believe that I'm right. Now let's try it with my uncomfortable strategy. 23 times 41. Okay, first thing I'm going to do is I'm going to multiply the ones by the ones. So 1 times 3 is 3. And then 1 times 20 is 20. I'm just going to put them all together. Right? 23 times 1 is 23. So that makes sense. 4, and so the one thing I always forget with this standard algorithm is that because I'm multiplying 4 tens, I'm just going to start, part of that shortcut is multiply everything by 10 and put my shortcut 0 there. So now I can just do 23 times 4, and my shortcut 0 is already in there. 4 times 3 is 12. 2 times 4, or 4 times 2 is 8, plus 1 is 9. Let me know in the chat how'd I do. Did I do that right? This strategy at this point is less familiar to me because I've done a lot less practicing with it. I think I did it. I got the same answer. So I think that's, pretty good there, right? All right. Thank you, everybody. I'll leave you with one more to try on your own. I'm not going to do it with you, but I'll leave you with one more to try on your own if you want a little bit of an extra, bonus challenge here. Let's do this one just to be challenging. 98 times 76. Let's flex our larger multiplication facts there. All right. Finish that one up. The exit ticket should be up on Google Classroom by now. So go ahead and get that started. If you have questions on this, or if you have questions on any content we have covered on this channel, or in 5th grade, or in 4th grade, or before that, if you want to come and practice addition, come to office hours. Let's practice addition. Adding stuff up is fun. You can do it anytime you want, and it's free. It's free entertainment. It's incredible. Thank you, everybody, for being here. Thank you for tuning in. Do that exit ticket. Hopefully, I'll see you at office hour if you have questions. If I don't see you at office hour, I know that you don't have questions and you are doing just swimmingly on your own. Thank you, everybody. Good luck. I will see you soon.